Hello, welcome to another edition of a quant skills lecture, if you will. We are in section 1C. There will be two videos for this section. The first part will deal specifically with the operations on sets, and then the second one later will deal with the Venn diagrams. So let's talk a little bit about the concepts here. Sets are just a group of things, all right? And a set of objects can be listed, or it can be enumerated, or there's all sorts of ways to write it. So I mean, a set can be something as simple as the people in your family, the list of people in your family, that's a set. All the students in the class, that's a set. All of your grades that you've earned, that's a set. With one exception, and that is that sets don't have repeats. Okay, so if you had 4 different grades, then that could be a set. But if you have the same grade twice, then now we can't list those twice. So when we're dealing with sets, we often need to set our parameters, no pun intended there, to make sure we know where we live. And that's what the universal set does. A universal set, it's denoted by capital U. We don't use the Greek letter C. We just use our English alphabet. And so we'll let big U represent the universe. And when you set your universe, that is where you live. And so if your universe has the numbers 1 through 10 in it, and that's it, then no other elements can be dealt with during that time. Okay, so once the universe is set, then we can start to talk about operations. There are 3 types of set operations we're going to learn about. We're going to learn about the complement of a set, the intersection of 2 sets, and the union of 2 sets. Okay, so the complement is denoted with a little tick mark, A prime. Okay, and what that means is that is everything that is not in the set A. It's everything else. Well, that's why you have to have a universe, right? So it's everything that's not in your set but is still in the universe. Okay. Intersection is denoted with this upside down U, almost a frowny face. We'll talk about that a little bit more. Intersection is the set that is in common to both. Okay, so we can think of intersection as and the union is when you have one or the other. So you can think of the union as or. We did and or, and I guess you can think of this as not really. And so those correspond to our logical connectives from section 1B. So let's do a couple of examples. All right, the universe for this set is 1, 2, 3, 4, 5. A is the set 1, 2, 3, and B is the set 2, 3, 4. Notice that each element is separated by a comma, and curly brackets denote a set. You must use curly brackets for your set denotion, okay? And then if you have elements, you list them. Order doesn't matter, okay? Order doesn't matter. If I write 2, 1, 3 instead, that's the same set as this, okay? But you need to use curly brackets and commas between your elements, okay? So find a complement. Complement is all the things that are in the universe but not in A. Well, A is 1, 2, 3. The universe is 1, 2, 3, 4, 5. So what are we missing from A? 4 and 5 are in the universe but not in A. And so that's the complement of A for this universe. Obviously, if the universe was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then my complement would be different. So that's why the universal set is so important to set first. Okay? A intersection B. All the elements that A and B have in common. A and B. And sometimes we can think of it as both. Right? Overlap. It's the overlap of A and B. So look at A. A is 1, 2, 3. B is 2, 3, 4. And so what are in common? 2 is in both. 3 is in both. And so 2, 3 is the intersection set because those are the overlapping elements of the set. Okay? The union, or, remember the union is or, and so it's everything in one or the other. Well, what's in A? 1, 2, 3. What's in B? 2, 3, 4. So it's everything in either set. But remember that sets do not have repeats. So I need to get rid of my repeated values to give me the correct answer. A union B is the set 1, 2, 3, 4. Okay? So there's one special set that I want you to be aware of. Okay, and that's the empty set. Some books will call it the null set. And that is literally the set with nothing in it. It's curly brackets, but there's just air in there. There's nothing in there, no letters, no numbers, no nothing. Okay, so that's the empty set. Another way to write it is 0 with a slash through it. Okay, so I will take this or I will take this, but be careful. All right, do not say this. Okay, it's one or the other. This is actually the set that has a set in it, the empty set, right? And a set of sets we're not dealing with. So don't write that. Pick one, either the empty set with curly brackets with nothing in there, or just the 0 with a slash through it. Okay, that's the empty set. If you ever have two sets, for example, that don't overlap at all, then their intersection is going to be empty. Okay, and we'll see something like that. So let's work a couple more problems. Here the universe is A, B, C, D, E, F. A is the set ABC, and B is the set CDE. And so now they want you to find A complement intersection B, just like we were doing when we learned logic in the last section. We could talk about and or and not, but then we created more complex statements that had multiple connectives in them. Here we have multiple set operations going on. And so in order to do A prime intersection B, first I need to find A prime, because I can't intersect two sets if I don't know what they are, right? So A prime here, what's A prime? It's the complement of A, everything that's in U that's not in A. Well, A is ABC, U is ABCDEF, and so if we get rid of ABC, A complement is DEF. Okay? So now I take B, which is CDE, and A complement, which is DEF. All right, so I'm taking A complement, and I want to intersect that with B, which is CDE. And what's intersection again? Intersection means that I'm the only way to get in, the only way I can possibly be in this set is if I'm in both. So D is in both, E is in both. So my final answer then is D and E only. Okay? So again, the way that I remember it, you can do it however you want, but the way that I remember it is intersection. That means both. That means hard to get in, right? It's rare to get in, or it's difficult to get in to the group because you have to be in both, whereas union is either one, and it's easy to get in. So intersection is kind of a frowny face because it's hard to get in, and U is a smiley face, right? Union, because it's very easy to get in, and everybody's in. Everybody's welcome with union. Okay, so I don't know if that helps or not, but it's the way I present it. Okay, so you guys try a couple. Here is a universe, A, B, C, D, E. A is CDE and B is ACD. All right, so I want you to try a couple of these. Note again, here we have A prime union B prime. So you have to find A prime first and B prime, and then you can do the union of the two. And then down here for 8, you're going to do A intersection B prime. You've already found B prime up here. All right, so pause the video, try these two problems, and we'll come back and talk about them. Okay, so what is A prime? What's the complement of A? A is CDE. It's everything else in the universe. That's A and B. A and B is in the complement of A. What's the complement of B? Well, B is A, C, D. What are we missing? We're missing the B and we're missing the E. So B and E is in B prime. Okay, so to do the union, I'm doing a union of AB, that set, with the set BE. What does union mean again? Union is everybody. Everybody gets in. A, B, and E. We just join it all together. No repeats. All right, so that's your final answer. For number 8, A is CDE, and then B prime we found for number 4 also. That's BE. And so if we intersect those two, what's in the overlap of these two guys? Only the E. E is the only element in the intersection of A and B prime. Okay? So, there's lots of problems for you to practice on. I want to help you kind of get some visuals maybe of what's going on. When we use Venn diagrams, which is going to be in the next section video, we use a circle. We use a circle to represent a set, and then we use the big square to represent the universe. Okay, you've got to have the big square. All right, and so what does A prime look like? Well, A prime is everything that's not inside of A but in the universe. So we would shade in, color in the stuff outside of A to represent A prime. Okay. Now, we don't know what these two sets do, but we do in general think of them as overlapping. So if this set's A over here and this set's B over here, then what does A union B mean? It's everything in A or B, and so it's all of this stuff. It's anything in either set. That's what the union means. What about the intersection though? What's the intersection look like? Well, again, we have to draw A and B overlapping. Okay, here's A, here's B, but now if there's an intersection, what's the intersection look like? Intersection is stuff that's in A and B both, only those areas, and so it's the overlap. It's exactly what the word I've been using. It's the overlap of the two sets. So that's what A intersection B looks like. So Venn diagrams help give us a visual to see what's going on. If you had an example here where the universe was A, B, C, D, E. A is the set A and C. B is the set B, C, and E. Then we can write out a Venn diagram like this. Make it a little bit bigger so I have plenty of room here. Here's A. Here's B. Okay, what's in the overlap here? C is in both of them, so I have to put C in the middle because that's in A and B. All right, A is in A but not in the middle. B and E are in B but not in the middle. And then notice that D isn't anywhere, so it has to be on the outside. Okay, so that's kind of a Venn diagram representation. We don't use this very often. We use the shadings a lot, but we won't use this kind of thing. This is just to kind of demonstrate how you could really get into it. But the second video that you're going to have for this section will go into much more detail about how we use Venn diagrams. I just wanted to introduce it to you. Okay, so practice your problems from your worksheets on sets and in your My Math Lab, and we'll see you later. Thanks.